You've seen the hype, right? These headlines about AI software engineers being totally ready to take over our coding jobs. But are they? I mean, really, how do we even know if these AI agents are genuinely good at problem solving or if they're just, acing a test where they've already seen the answer key? Well, today, we're going to find out.
So, here's the plan for this explainer. First, we'll dig into the massive problem with how we're currently testing AI coders. Then, we're going to meet the new sheriff in town, a solution called SWE-Bench Pro. We'll look at exactly how it was built, check out the, pretty sobering results, and then try to figure out what this all means for the future of AI in software development.
All right, so let's get right to the heart of the matter. The way we've been grading AI on coding is, frankly, a bit flawed. Imagine giving a student an open book test, but the book they're using is the exact one they studied from, with all the answers highlighted. It doesn't really test if they understand the material, does it?
Exactly. It's like a driving test in an empty parking lot. An AI can look like a total pro, nailing three-point turns and parallel parking with no cars around. But what does that tell you about how it'll handle rush hour traffic or a confusing five-way intersection with a broken traffic light? Nothing. The real world of software is messy and unpredictable, and our tests need to be just as tough.
This whole issue really comes down to two big, glaring flaws. First, what's called data contamination. These AIs are trained on a mind-boggling amount of public code from places like GitHub. So there's a really good chance they've already seen the test questions and the solutions during their training. And second, the tasks are often trivial. Come on, asking an AI to fix a one-line bug doesn't prove it can handle a complex new feature that touches 10 different files and requires a deep architectural understanding of a project.
So, to fix all this, some brilliant researchers at Scale AI decided to build a new benchmark, a much, much harder one. Say hello to SWE-Bench Pro. It's been designed from the ground up to be a genuine test of an AI's ability to do the kind of gnarly, complex work a real software engineer faces every single day.
So what is SWE-Bench Pro in a nutshell? Think of it as an advanced obstacle course for AI coders. The challenges are purposely realistic, they're complex, they require long, detailed solutions, and most importantly, it's designed to be cheat-proof. This is the real-world driving test we've been talking about, not that sleepy parking lot. And this slide, wow, this really puts it into perspective. On the left, you've got the old benchmark, where a huge chunk of the tasks were tiny, like 1 to 5 line changes. Now look at the right. That's SWE-Bench Pro. It doesn't even bother with tasks that small. The problems start at 10 lines of code and go way, way up from there. The difference is just night and day. And get this, here's the number that really tells the story. The average task in SWE-Bench Pro requires changing more than 107 lines of code. We are so far beyond simple bug fixes now. These are what they call long horizon tasks, the kind of stuff that would take a human engineer hours, maybe even a full day, of deep focus and making significant changes all over a code base.
So how in the world did they build a test this good? I mean, it's one thing to find hard problems, but it's another to curate them so they're fair, repeatable, and contamination-proof. This is where the methodology gets really, really clever.
It all comes down to this meticulous 3-stage process. And here's the secret sauce. It has expert humans involved at every single step. First, they source problems straight from the commit histories of real-world software projects. We're talking actual bugs and feature requests. Then, and this is so important, human software engineers step in to augment these problems. They write crystal-clear task descriptions, adding all the context that's usually missing from a messy commit message. And finally, they create and verify the entire environment to make sure the test is perfectly reproducible every time. It's that human touch that turns a simple problem into a professional-grade engineering task.
And because of that process, every task in the benchmark has this really clean anatomy. You get a problem statement that reads like a perfectly written ticket from your project manager. You get a requirements section that spells out exactly what a successful solution needs to do, so there's no guesswork. And for some tasks, they even define an interface, telling the AI the exact names of functions or classes it needs to use. This is smart because it stops an AI from failing just because it had a perfectly good solution, but called a function something different. Okay, but what about that data contamination problem? How did they stop the AIs from, cheating? This is my favorite part. Their strategy was brilliant. They sourced code from two places AIs are unlikely to have trained on. First, repositories with strong copyleft licenses like GPL, which are a legal headache to use in commercial training data. And second, they got their hands on private, commercial code bases from actual startups. The combination of these two things makes it almost certain that none of the models had seen these specific problems before.
Okay, so we have a much harder, much fairer test. The moment of truth has arrived. How did the most advanced, state-of-the-art AI models, the best of the best, actually perform? Well, folks, this is where we get our big reality check.
Just take a look at this table. We've got some of the most powerful models in the world here, and the top performer, Claude Sonnet 4.5, only managed to solve 43.6% of the problems. Let that sink in. Even the very best model failed more than half the time. This basically resets our expectations and gives us a brand new, much more realistic baseline for what AI can do right now.
This bar chart just makes that ceiling crystal clear. You can see the top 3 models are all bunched up right there around the 42 to 44% mark. It's not like one model is blowing the others out of the water. Nope, they're all hitting the same wall when faced with the real-world complexity that SWE-Bench Pro throws at them. And just when you thought it couldn't get any tougher, it does. Remember those private commercial code bases they used? Well, when the AIs were tested on that code, their performance absolutely cratered. The best models solve less than 20% of the problems. This just goes to show how much harder it is to work on messy, proprietary, enterprise-level code than on clean, well-documented open-source projects. So what's going on? Why are they failing so badly? Let's break down the reasons for one of these top models. The single biggest reason for failure at almost 36% was just submitting a wrong solution. And this isn't about a simple typo or a syntax error. This means the AI produced perfectly valid code that was just plain wrong. It didn't solve the actual problem. The core issue here is a deep lack of problem comprehension.
So, what's the big takeaway from all this? These results draw a very clear line in the sand. They give us an honest look at where AI stands today. And more importantly, they give us a roadmap for where we need to go next.
You know, the researchers themselves summed it up perfectly in their paper. They said there is a critical gap between current agent capabilities and the demands of real-world development. The hype might be way out ahead of the actual technology, but benchmarks like this are exactly what we need to ground ourselves in reality and measure true progress. So if you remember anything from this, remember these things. 1. Our old tests were basically giving us fake good news. 2. SWE-Bench Pro gives us the hard truth. 3. Even the most powerful AIs are not ready to be fully autonomous software engineers. Not yet. And finally, this tells researchers exactly what to work on. It's not just about building bigger models anymore. It's about teaching them how to actually think, how to break down complex problems, how to use tools properly, and how to self-correct when they make a mistake. That is the huge mountain that AI still needs to climb.
Okay, I get it. After all those charts and tables and failure modes, your brain might be feeling a little, benchmarked itself. If you're in need of a serious vibe check right about now, you know exactly what to do. Go ahead and smash that subscribe button for Vibe Doc, where we make more complex topics make sense.
And we'll leave you with this final thought to chew on. SWE-Bench Pro has shown us the what, this huge gap in performance, but the why is still a massive open question. What do you think is the key ingredient, that one missing piece of the puzzle that will finally let AI master the complex, creative art of software engineering?